Hey, what's up guys? Andrew here. Today we're going to be doing another coding challenge from LeetCode. This one is called AddTwoNumbers, and I'm going to go ahead and share my screen with you. Alright, so we are given two non-empty linked lists representing two non-negative integers. As you can see down here, they have an example. The digits are stored in reverse order and each of the nodes contain a single digit. Add the two numbers and return the result as a linked list. And this is their sample result. So we may assume that the two numbers don't contain any leading zeros except the number 0 itself. Okay, cool. So let's take a look at their example. So 243, as you can see here, this is backwards because it's actually the number 342. And 564 is really 465. So they're trying to ask us what 342 plus 465 is, and they want the answer also in reverse order as 708. So one thing we can note is that the order is the same both in the solution and in the parameters that we are given, meaning that the first digit is the least significant, meaning it's the in the decimal system it's the ones multiplier. In the second digit is the tens multiplier, and the third digit is the hundreds multiplier. So I'm just going to go ahead and switch on over to a paint application so we can just go over the basic math. So let's try something simple like 700, actually 983, and then plus 99. Now let's go ahead and review how we would have been taught to do this, at least from where I'm from. So the way I've been taught to normally solve an addition problem like this is exactly the same way that we're going to solve it via the computer, because it's a tried and true method for solving addition. So what we do is we start here, we check vertically. 9 plus 3 is 12, and we see if I can do a dotted line. No dotted line. Okay, so whatever. So we have 12 here, and we have to check if there's something called a carryover. I'll write this down. Be so big though, but whatever. So carryovers are normally what are written in this section right here. Okay, now that we've gotten that out of the way, so we have 9 plus 3 is 12. So we write, if the value is over 9, we take one of those decimals and put it over here. Maybe black and a thicker line. So we put the 2 down here, and then we continue moving to the left. Now we're looking at this column. So 9 plus 1 is 10, plus 8 is 18. So we have 18, and 9 plus 1 is 10. So once again, we carry the 1 here and put a 0 here. And then finally, we have this extra left over 1, which we just add up. We essentially, what we're doing is 1 plus 9 plus 0, and here we're doing 1 plus 0 plus 0. So I could like use a different color. I don't know, dark blue, that's good. So I'm just going to write in 0 here, 0 here, and 0 here. So Yeah, you get the idea. So this is the same exact algorithm that our computer is going to do. So let's go ahead and get on with that. So let's go back to the web browser and let's put that into code. All right, so in order to do that, we need to do a couple things. First off, it's kind of an anti-pattern to mutate directly the function parameters unless you're intentionally trying to do that. So, I mean, either regardless of whether it's an anti-pattern or not, I'm just going to go ahead and store a copy of the pointers to these lists. So I'm going to call the first one list1 iterate. Let L2 iter equals L2. So now we can change these pointers around with and still have access to the original values of L1 and L2. I mean, we might be changing the objects internally, but these pointers will still point to the original place in memory. And now we can do whatever we want with these two values here, these two variables. All right, so let's go ahead and continue. So what do we want to do? We want to add. So we're going to have a result. So and also we're going to have a carryover. At the beginning, when we were adding, if we refer back to our Microsoft Paint, the carryover was 0 to begin with right here. So that's why I'm initializing carryover to be 0. And now we're just going to loop. We can assign it just to always loop until, and then we'll define explicitly the exit condition. So we need to calculate the value or the sum of that. I'm going to call it column sum equals L1 iter. All right, sorry. We can see up here that the actual value at the given node is stored in the val attribute. So we pull it from there. Okay, cool. So this is the summation of those three values. And now once we've already used the carryover value of relevance, we can reset it to 0 because we already used it in our calculation. So we're setting to 0 for the next time through the loop. So when we're on the second column, we won't be accumulating from a previous column's carryover value. Okay, so next on, so if the column sum is greater than 9, this is the special case when we need to assign there to be a carryover value. So we assign it to equal to 1, and then we say val equals val minus 10. Alternatively, we could do val mod 10 with the percent sign. Both of these would achieve the same result. Doesn't really matter. I don't know. Minus 10 just sounds like it would be easier calculation for the computer at least. Okay, so next, what do we do? So if we need to initialize the resulting list somehow. So we're going to be storing that in the result object. So if we don't already have that object created, that's what the exclamation mark does, is it evaluates the truthiness or the falsiness of the result object. So if it's not created, then we'll execute this code block. If result evaluates the false, which means that it's going to have been an empty object. So if we haven't already created the result object, let's go ahead and create it. They have the function definition up here at the top. So we pass in the value for the given node. Oh, sorry. Here I wrote val. I meant to say column sum. Okay. And when at the very end of this, we're going to want to be able to return the pointer to the start of this linked list. So I'm going to actually have a separate variable that'll allow us to iterate through the results linked list without losing the pointer to the original start of the list. So we're going to keep that separate. So this one's always going to point to the start of the list, and this one is going to allow us to kind of go through it. Okay, so we create the list, and then we set the iterator to the start of it. And then if there already is a list in this current iteration of the columns, then what we're going to do is we're going to say the next node in our linked list is going to be a new list node with the given value. And then we're going to move our iterator to the new node that we just created. And then finally, if we need our exit condition. So we need to exit when both there's no next value for either of those, for either of our numbers. So for example, if we were at the 4 and the 3, there'd be no new values to add. So we're going to go ahead and check that. So if the list 1 iterator doesn't have a next, and the list 2 iterator doesn't have a next pointer, then we're going to just break out of this loop. And otherwise, we're going to kind of increment to the next pointer for each of the numbers that we're adding, which essentially is going to the next column. And if you think back to how we're kind of moving leftwards in columns right now, this is what we're doing in our code. So if there is a next pointer, we're going to move to that next pointer. Otherwise, we're going to make a node with value 0 and go there. So that's essentially what we're doing right here when going from the 9 to the 0. Because since there wasn't a value there, we're just going to pretend there was a 0 there. So that's what we're doing when we're if there's no next value, we just pretend it's a 0. I'm just going to go ahead and copy paste this. Oops. And just change the number 1 to 2. All right. And last but not least, we need to handle the final carryover. So after we loop through everything and there's still a carryover at the end, sorry, if there's a carryover at the end, then we go ahead and say we create a new node for this last carryover value. And we put it in our result linked list via the next pointer. We say the next node is this carryover value. And then at the very end, we go ahead and return the resulting linked list. So let's go ahead and run this code. Cool, it was accepted. Let's go ahead and submit it, which does a more lengthier test. And cool, we got a 97, we're faster than 98% of the online JavaScript submissions. Cool, so that was successful. Let's just look at it real quick. So essentially we're looping through the numbers. So we only loop through them once. So that's pretty much as efficient as you can get. At least to my knowledge, there might be some nanoseconds faster you could get, maybe some like binary bit operator type stuff or something, but this is efficient enough. I mean, you try to optimize your code, but at some point it's fast enough to say that it's not really worth optimizing it anymore unless you have a really, really compelling reason to do so. So for most applications, as long as your code is fast enough, you're good. You don't really need to nitpick such things unless there's some really special requirements or there's already some performance issues in your code. So anyways, there you have it. This is my code, and this was AddingTwoNumbers from LeetCode. If you like this video, go ahead and press the thumbs up button and the subscribe button so that you can stay tuned for future videos where I'll be doing more algorithmic type challenges in JavaScript. See you guys.